Let's take a look at some applications of proportions. These problems here are also known as the shadow questions, like some of us did last year with the flagpole, with the light pole, and with the windmill across the street. So here's our question. The totem pole shadow is 45 feet. A 6-foot tall man casts a shadow that is 3 feet. How tall is the totem pole? So let's take a look at our picture. Here's my totem pole. We don't know how tall it is, but we know that the shadow is 45 feet. We know that the 6-foot tall man is casting a 3-foot shadow. So setting up our proportion, there are many ways you can do this. So I'm just looking at the height of the object over the shadow. So the height of the totem pole we don't know, but we do know that the shadow of that object is 45. The height of the man is 6 and the shadow is 3. By looking at cross products, we can get 3x equals 45 times 6, which gives you 270. And then dividing both sides by 3, x equals 90. So because we need a context sentence, the height of the totem pole is 90 feet. There are other ways you could do it. You could put the shadow on top. You could put the heights of both people, as long as your labels are consistent, which is why I set up this on the side, just to keep me focused on where my numbers would go. Let's take a look at another problem. Here's another example. A 16-foot tree casts a shadow. A 2-foot pole has a shadow of 1.75 feet. How long is the shadow for the tree? So there's our tree, there's our pole. So we know that the tree is 16 feet. We don't know the shadow. We know the pole is 2, and the shadow is 1.75. So now I'm going to do the height over the shadow is 16 over x, and this is going to be 2 over 1.75. So 16 times 1.75 is the same as 2x. So I'm going to write up here, 28 is the same as 2x. Divide both sides by 2. And you get 14. So I hope this helps. We're going to do a few practice problems on page 124, numbers 4, 8, and then 18.